Okay, I think the time is up, and I think it's time for us to go ahead and get started. So I know that we are now gradually entering into like a holiday mood, right? You know, starting from yesterday, that usually marks the start of the holiday season. But here at Cornell Systems Engineering, while you know we have a light holiday mood, but we do serious research. Right, every one of you do serious research. Particularly today, we're very happy to actually have Graeme back to visit with us. Some of you might know Graeme. Actually, Graeme did his PhD here at Cornell Systems Engineering. A very proud graduate from our program of our own. So actually, you know, Graeme, he did his research on system architecting urban infrastructure system, and he's really, and I think doing the research, and also I feel that based on your research, you probably naturally pick up a role of advocating for a paradigm shift of building better infrastructures, building better communities, and a better world. So and currently, Graeme is a postdoc fellow at Colorado State University, where I believe he's kind of keeping pushing forward, you know, his research agenda as well as his research vision. So one thing I want to mention that actually, you know, a lot of you, right, you are either MA, PhD, or MS actually. So Graeme, actually, by the time he graduated, he was actually even, you know, he's already had a book contract with Cambridge University Press, and I think he finished the majority of his book manuscript. Now he's getting the book published, I think, in the last 0.2 mile. Yes, so today Graeme is going to really talk about this. I think this is really important topic. You know, the decision support tool, particularly, it's not only a tool, it's really a decision support, a decision paradigm for urban social technical systems. Here he's using urban social technical system as an example, but I believe that his research framework can be applied to any social technical system. So Graeme, it's all yours.
Yeah. Thanks, Oliver. Hey, everybody. I'm really delighted to be here. Some of you know me because we shared an office briefly. Others, I'm the person that you email when you have questions or problems with this class. So it's nice to actually see everybody in person for once. So before I get started, I just kind of want to preface, you will not be responsible for a response to this seminar, the first time and master students, so you can take the week off. And I also want to just say how excited I am to be the excuse for lunch this week. So yeah, like Oliver said, I'm a graduate of the PhD program. While also being a visiting lecturer here and sort of helping out with this course and complex systems, SysN 6000. I'm also a postdoctoral fellow at Colorado State University, where I've been doing some research sort of somewhat related to my PhD work, but sort of expanding upon it a little bit. So, and that's essentially what I'm going to talk about today is developing decision support tools for socio-technical, urban socio-technical systems, and why I think that's important, why I decided to sort of focus on that aspect with my research. And then at the end, I'm going to sort of wrap up with my sort of research plan moving forward. Quick agenda. I'm just going to sort of provide again like my motivation for this sort of work, and then I'll give a brief account of urban socio-technical systems, why they matter. Then I'll talk about some of my PhD research, applying systems architecture to the early stage design of urban infrastructure. And then after that, I will kind of walk through some more recent work during my postdoc about improving energy efficiency in the rental housing market, and kind of the way I've been approaching that, particularly from like a decision support perspective. And then, like I said, I will wrap up with sort of future research plans moving forward. So why I'm interested in decision support and urban sociotechnical systems in particular, cities and towns are facing a lot of uncertainty and unpredictability. From, at least from my perspective, a couple of trends. One of them obviously is the increasing frequency of extreme and very expensive weather events. This chart here is from NOAA, just kind of showing the increase over time of billion-dollar disasters, and starting at 1980 and then continuing up through 2024. So they're increasing in frequency, they're increasing in overall cost as well. And I mean, we've had a few even recently, right? So that's from the top left photos from Asheville, North Carolina, which saw flooding as a result of a hurricane, which is somewhat unprecedented, and was a big problem. But then also kind of out in Colorado and that neck of the woods, there's increasing frequency of wildfires and things, landslides and sort of soil erosion as a result. So depending on where you are, these climate events are going to be fundamentally different and pose different sorts of threats. And so decision-making in response to those should also, needs to be sort of regionally contextualized and nuanced. The other sort of trend that sort of helps motivate my focus on urban areas in particular, the global urban population as a percent of total population has been increasing at a fairly steady clip for a while. So that means more people are deciding to move to or live in urban areas, and that between these two things, interestingly enough, leads to a bit of a feedback loop, because an increasing share of global greenhouse gas emissions over time is actually attributable to cities and towns, in part because of this population growth. So even though, and I'm sure many of you hopefully are familiar, urban areas are person to, or by person more efficient in terms of their energy use and resource use. As more people go there, they are still more responsible for an increasing share of global greenhouse gas emissions. So it means there's a lot of opportunities in urban spaces for looking at ways to reduce greenhouse gas emissions, to improve how infrastructure operates, and to look at how to improve decision making in order to address these sorts of problems. So, urban sociotechnical systems, what I mean by that are essentially large, distributed, often legacy systems. So infrastructure, kind of like Oliver mentioned, is a sort of classic example. So they're typically characterized by deep interdependencies and interconnectivities, both on sort of physical and informational sort of connections. But then also in terms of like social connections, which are typically excluded from sort of engineering analysis. Obviously, like a wastewater treatment plant needs energy and needs some sort of telecommunications in order to interact with other people, but also the people running that plant also rely on all of these other systems too. And so you have this sort of this deep lattice of dependencies, both at the physical infrastructure level and then also at sort of the social level, which makes things pretty complex. And then the other issue, kind of like I hinted at in the last slide, is that these systems have sort of unique regional needs. So their characteristics can be sort of tied to demographic, geographic, economic issues that are unique to that region, or sort of the idiosyncrasies of the legacy systems themselves that are unique. But then also to sort of look back at the social dimension, priorities, right? A community's priorities might differ one to another. And so they might, say a community might be more interested in prioritizing development in one part of the world or in one part of the country, whereas others are maybe more focused on climate action and might prioritize that in their decision making, or improving livability in their community or something like that. And so with all of this sort of in the background, this kind of, it makes decision-making for like both policy and the physical design of urban systems particularly difficult. And that's sort of compounded by the idea that, or the fact that urban decision makers and policymakers and urban planners have to balance the needs of different stakeholder groups in their community, in addition to any sort of technical objectives that they might have from these systems. And so looking at the way these decisions are made, in my PhD research, I got pretty interested in applying systems architecture to the early stage design of urban infrastructure. And as my case study for applying this, I looked at the revitalization of the Brooklyn-Queens Expressway in Manhattan, or in Brooklyn. Specifically, I looked at the triple cantilever section around Brooklyn Heights, and then also the below grade section down near Cobble Hill and Carroll Gardens. And the reason why this ended up being like the reason why I chose this as a case, as a test case, is because this project, this was needed in 2006. So City Council started considering ways of revitalizing this strip of the BQE in 2006, and when I started looking into this in 2018, they still hadn't made a decision. This report, The Future of the BQE, came out in February of 2020, and it was collecting the 7 alternatives that the City Council was going to consider. So it took them 14 years just to get to that point. And one of the reasons why was because it got pretty contentious pretty quickly. There's a lot of different stakeholder groups and community groups that have a serious vested interest in this strip of the BQE, and so it was almost perfectly set up for a contentious, prolonged, protracted sort of decision-making process. Some of the alternatives in this report were actually funded entirely by community groups rather than by the city at all, which, if anybody knows anything about these proposals, they're extremely expensive. You have to hire a third party, usually some engineering design firm or somebody like that, to do them. And they provide a single solution at the expense of usually several $1 million at least. That also takes a long time. So this was, and I think just within the last few months, a final decision has been made. So in the meantime, not only has all of this been taking forever and everybody's getting really upset, but also during that time, the city has had to invest money in just keeping the current triple cantilever section of the BQE in operation. So there's a considerable expense wasted through this whole process, and everybody's just now really upset. So I wanted to look at, well, how could systems architecture help and sort of restructure the decision-making process and help reground it and reorient it towards the things that actually matter, right? How to integrate stakeholder voices and priorities, and look at and use that to evaluate a larger set of decisions or a larger set of options. So, just quick for has anyone taken systems architecture, that course? Couple? Okay. So systems architecture is a pretty neat approach. So it focuses on sort of the early stage design exploration for large projects. And it does this by modeling and evaluating early stage design decisions. It helps to identify among other things, it really focuses in on identifying the decisions that make the biggest impact on cost, performance, and other sorts of metrics. And it highlights the first like 12 to 20 architectural decisions. So there's a lot more engineering that comes down the road. But the reason why systems architecture is great is because it formalizes the really the early decisions so that you have a much better understanding of what the likely eventual cost and schedule, timeline, and other sort of performance metrics of interest are going to turn out to be. So essentially, it reduces uncertainty in the total project space by formalizing the early sort of often implicit functional and formal architectural decisions. The process essentially goes through stakeholder analysis, concept exploration, architectural enumeration and evaluation, optimization, trade space analysis, and then eventually you select and document the architecture. So when I wanted to apply this to the BQE example, obviously I wasn't going to spend 18 years in city council meetings for the stakeholder analysis part. So I really leveraged that report, actually, that I showed on the previous slide, the future of the BQE, which is a great resource because it ended up having a thorough description of all of the proposals under consideration and all of the sort of alternatives or decision alternatives in there. Also, it mentioned quite a bit about different stakeholder needs, stakeholder goals. So it provided a lot of the information that I needed to really develop an architectural trade space. So I started with, again, those initial decisions or those initial proposals. I ignored two of them because they were just wildly different than the others. And so in the interest of sort of both, honestly, time as a PhD student and also making the trade space easily comparable, I focused on the 5 that were really revitalizing the BQE rather than just entirely doing away with it. And from there, like I said, I extracted decisions and decision options and identified 10 different architectural decisions and the options for them. Enumerated, or from there I identified the infeasible sort of combinations of some of those decision options and was able to enumerate the trade space. So unconstrained without any of those, with all possible architectures, including the infeasible ones, had 27,648 architectures. The constrained architecture space that was that excluded all the infeasible architectures was about 4,600. So already, just intuitively, right, this was drawn from 5 design alternatives, 5 proposals. Just what's the likelihood that any of those 5 offer sort of an ideal trade-off between stakeholder objectives? Basically 0, right? So, so already this is starting to get to why I think this is a better approach to making these sorts of decisions. Not only could I do this way quickly and on my own, or really quickly, way quicker than 18 years and on my own, but also I ended up with way more feasible options to choose from. And I evaluated all of those just using a very simple bottom-up cost metric, performance, which is essentially a Green Shields model that estimates flow, a maximum flow for the year, and air quality. So the air quality is essentially a stand-in for community, more community-focused objectives. There were quite a few others listed in that report and others, but air quality was one that showed up a lot, and certainly right along that strip of the BQE, the air quality can be pretty bad. So essentially, I wanted to look at what trade-offs exist among these architectures drawn from their design alternatives, evaluated according to these metrics. So when evaluated, obviously it's going to make a 3-dimensional trade space. This one here is just the Pareto front, this is the fuzzy Pareto front. And, you know, there's a couple of interesting characteristics about the trade space that I think is worth highlighting. One is, you know, you have these sort of two distinct groups, right, of architectures. That grouping is determined by both a little bit of the air quality metric and also the flow metric. So the flow metric, essentially because it's a green shields model and it uses sort of like throughput and design speed and the number of lanes and the size of the lanes and everything like that, there's only so many lanes that you can have, right? And there's only so many different like lane configurations that were present in those 5 alternatives. And so that's a bit of a contribution to this gap is, you know, there's I think 4 lanes, 6 lanes, and 7 lanes. So part of it is the difference between 4 and 6 lanes and the amount of vehicles that the roadway can accommodate between those two. Then the other one is air quality, and basically for a very similar reason. So given the number of vehicles that can drive along the roadway per year, that's going to have an impact on air quality, right? And also, one of the design decisions involves capping the below grade section of the BQE along Cobble Hill and Carroll Gardens, and that's going to have an enormous impact on air quality, right? If you cap it and cover it in green space, all of the emissions under that cap section are going to be filtered in some way, so that reduces air pollution in that area. So that's essentially why there's those two groupings and sort of their structure. And then, so that's kind of the shape of the Pareto front and sort of why the architecture space looks that way. But down here I also have a couple of different decision scenarios mocked up. And these are also drawn from that report. So first here, this parallel coordinates plot is just the full trade space. You know, each vertical axis represents a metric. The second chart here, this is down selected based on one of the decision scenarios that was evident in the report that would prioritize flow through the BQE for economic reasons, but say they wanted to also minimize, given maximizing flow, wanted to minimize impact on air quality. Well, you can already start to see the trade-offs from that by prioritizing the metrics in that way, right? Higher flow means you have to accept a certain higher threshold from air quality. Similarly, some of the stakeholder groups, community groups in Brooklyn Heights in particular, were really keen on reducing or improving air quality, so reducing particulates in the air. And they were fine with reducing the amount of traffic that the BQE could accommodate to do so. And so again, if you constrain or you prioritize lowest possible contribution to air pollution, then that's also going to mean you have to accept a certain lower amount of throughput, which might have an economic impact, right? Businesses may not be able to get the goods that they need, grocers or otherwise, as easily as they could with more lanes or something like that. And so just being able to sort of visualize and explore the trade-offs between these different objectives like this, where we're looking at, first of all, significantly more potential designs for this project, and also they're evaluated all according to the same set of metrics. So it allows us to have a much more grounded conversation about what we as a community want, right? What do we want to prioritize and why? What are we willing to sacrifice for that? Rather than, you know, these different proposals funded by different people that obviously are, you know, entirely serving their own interests, and it's very difficult to sort of compare between them. Digging into the trade space a little bit further, These charts up here are essentially looking at the sensitivity and connectivity of each metric. So this is cost, this is flow, and this is air quality. The two decisions that cost is most sensitive to and most connected to were, let's see, support type and whether or not the south section of the BQE is capped, which makes sense. Capping a roadway, a below-grade roadway, is really expensive. It's a lot of additional engineering just to make it be able to support the cap and all the stuff on top of it. So that makes sense. And then support type was actually really heavily connected to a lot of the other sort of architectural decisions, because it essentially determines how much of other stuff you need, whether it's concrete or something else, right? And how big the roadway can be. For flow, that's really the lane configuration is what it's most sensitive and connected to, which makes sense, kind of like what I was saying earlier. More lanes means more vehicles, right? So it should be there. And then same with air quality. Air quality, more vehicles means generally worse air quality. And down here, I also represented, so I selected 3 architectures here. One of them is from the rank 1 Pareto front. The other 2 are from rank 2 Pareto front, which the reason why that's beneficial is sometimes you get better trade-offs on the fuzzy than you do on the actual Pareto front. And then I represented their impact in air quality on the different air quality monitoring stations along that section. And what you see essentially is that this is the rank 1 Pareto front architecture that I selected. And it's probably hard to tell, but you really can't, there's not much of an impact on air quality here. It makes it a little bit better, but not a ton. Whereas these two from the rank 2 Pareto front offer significantly better gains. Oh, sorry, ranks 3 and 2. So, you know, what this is, the reason why this is beneficial is not just because you can have a more grounded conversation with stakeholders over sort of against the backdrop of shared information and common information, but also now, since you know what decisions make the biggest impact on the things that matter to you, you can really focus the conversation on those and say, like, okay, some of these other things they have a negligible impact comparatively, so maybe let's, you know, if we can't all agree on ultimately what we want to prioritize, maybe we should just prioritize those 3 decisions. Maybe we can just start there, and then we can have an engineering design firm or maybe the in-house folks mock up a few alternatives moving forward. But at least you can get to something, you know, and likely much faster than 18 years. So key findings. Systems architecture, I think, holds a lot of promise as a decision support tool for these sorts of infrastructure design decisions. Like I said, the fuzzy Pareto set offers better trade-offs than the proposals considered. And actually up here, one thing I didn't have in some of those earlier charts, so these are the 5 proposals, and none of them are even on the fuzzy Pareto. The closest examples of those in the trade space are heavily dominated. So not only, so they might, I guess, be you know, reasonable proposals or good proposals, sort of examined on their own merits. But when you're focused on finding architectures that provide a much better trade-off between known community and stakeholder objectives, none of them are probably the way to go. Also, like I said, systems architecture really holds promise for supporting informed discussion regarding goals and priorities, rather than those differ, and so I'm going to fund a different project, and we won't really be able to talk about anything in common. Having this as a backdrop really lets you look at, well, what do we want to prioritize and why, according to the same set of metrics and the same shared information. Moreover, it can be made iterative, which is really neat, but that's starting to get into some of my future plans, so I will save that for a little bit later. Next, so that was what I really focused on during my dissertation. What my it's like one chapter of the book. So if you want the rest, it should be in a bookstore near you shortly. Shameless plug. But I'll move on to some of the stuff that I've been working on during my postdoc. So again, I'm really interested in sort of how systems engineering tools and taking a systems approach can really help with making decisions in urban areas and urban contexts. And there's this one sort of challenge with energy efficiency in the rental housing market, and that's that there's this incentive gap. So, if you think about it, landlords aren't clearly going to be incentivized to improve the energy efficiency of their units because their tenants pay for the utilities. So it's really hard to find policies that incentivize landlords to make improvements that they don't reap direct benefits from. And in order to sort of dig into this, I was really fortunate to partner with Dr. Steve Conrad at CSU and Reuven Sussman at ACEEE. And they had done some previous work on looking at how presenting energy efficiency information in rental listings actually can change people's willingness to pay or affect people's willingness to pay for rent. And so they had this great discrete choice data set that I could sort of play around with. And so I thought, well, why not look at developing some sort of a way to simulate or explore the impact of various policies, regional policies on the rental housing market and its value. Sort of as a way to think about how could we incentivize landlords to make upgrades? What policies make the most sense? So I took that data set and conducted a latent class analysis, essentially just to identify the unobserved subgroups within the population that might be sort of driving, or to better understand what might be driving sort of preferences and choice behavior. I found 6 classes, and among them, you kind of get the spread. There's single renters, there's large families, there's high income, low income, different education levels, different employment statuses, all sorts of things, different regions. And in that model, I also included a bunch of covariates that basically just map to census data. So like how many people in the home, and income bracket and things like that. And from that, I was able to estimate likelihood of class membership based on covariates. And so with that sort of information, I was able to build a policy decision support tool that essentially any municipal decision maker or regional decision maker could put in the rental housing stock characteristics of their region or their city. They could put in geographic characteristics, so climate, the type of climate, and whether or not it's like what its moisture regime is, and then also sort of demographic characteristics of their population. And critically also, I think not on here, but there's also, there's also a percent of units with specific home energy scores. So if we're going to incentivize improving home energy efficiency, right, in the rental market, we need to know roughly how energy efficiency is broken down in the rental market. And so for that, there's some great data from the Department of Energy on home energy scores throughout the country. The rest of that data can basically just come from either housing and urban development or the census. And from there, could look at, well, if you improved some percentage of rental units in that region from, say, a home energy score of 2 to a home energy score of 5, how is that going to change the value distribution in the rental market? So this is for, I think, Durham, North Carolina. And so before the policy, so this is policy agnostic right now, but before the policy, if you're able to increase, I think it was 15%, or improve 15% of low energy efficiency to essentially meet a median energy efficiency, there's a lot of sort of money left on the table. Whereas, like, if you just kind of compare home energy score 5 between these two, the pre and post, you see tenant or the value of those properties has eaten up a bunch of the value lost to energy bills. And so too with home energy score 8. Better way to show it here is actually right here. So this bar here is before the upgrade. This is after. So that difference plus a little bit is essentially gone into the pockets of landlords instead of the energy utility. So that's additional value that can be added. And so, like, on a per unit basis, estimated average monthly value gain per unit is around $279, which is money that the tenant is directly saving on energy bills and can pay to rent instead. So that's all really interesting, but digging into it a little bit more, there's sort of some interesting trends when you look at this sort of region by region in a bunch of different areas throughout the United States. And one thing that becomes clear is that tenants are generally willing to pay more in rent than they save in energy costs, which is sort of counterintuitive. You would think that it should be ideally like 1-to-1, right, or something like that. Turns out it's more, and the reason why is really interesting. So in wealthier or higher cost of living areas, it's closer to 1-to-1. The willingness to pay is a little bit, but not much more than energy savings. And the reason for that is because, at least I think, my hypothesis, is that efficiency is intrinsically valued more. So the interest in energy efficiency, improving energy efficiency, is sort of its own good in a higher cost of living area or wealthier area. So like in San Diego, for instance, the per unit value gain is lower than the average energy bill. So it's still about 1-to-1 or close. And so if we, in areas like that, to improve, you need a different set of policies in order to improve energy efficiency, right? And so it looks, the suggestion that looks most promising is essentially more favorable taxation laws to add to the gain that property owners would get from the improvements, because essentially the potential rent increase is lower relative to average rent in those sorts of areas. But what's really, I think the more interesting insight, I think, is in poorer or lower cost of living areas. What's valued is not so much energy efficiency, but stability. So it turns out a lot of those areas also, people are often or more frequently surprised by high energy bills. And so that is a significant driver for their willingness to pay more for rent, for increased energy efficiency. So they're happy to pay more as long as it's consistent, rather than being surprised by a bill that means they might have to move out. And so that's in a sense easier to incentivize, at least from a more economic perspective, for landlords. In large part because the potential rent increase is much higher relative to the average rent in the area. So if you look at like Houston, average energy bill per month is actually lower than the per unit value gain estimated, the estimated willingness to pay for a more efficient home. And same with Durham, although it's somewhat less dramatic. And so what's being priced in there is really people's interest in stability on top of energy efficiency. So here, the policy recommendation is mandatory minimum, imposing some sort of mandatory minimum energy efficiency standard to kind of get the ball rolling, and subsidies to make that easier to implement. So it's required, but also we'll make it cheap, and then it'll pay off very quickly. Yeah, so that's so with that sort of an exploration tool, it helps sort of inform policymakers in particular. Give them a way of exploring a pathway to improving the energy efficiency and like the load on their energy grid and things like that in urban areas, which the lion's share, or quite a bit of that, comes down to inefficient housing, which is largely rentals, more likely to be rentals. So there's just sort of a couple of examples of things that I've been working on, but as I kind of look forward to the next couple of years, early stage career, I want to really kind of piggyback on both of those things to develop something that's a little bit more implementable, rather than sort of these one-offs, and something that I can actually put in the hands of urban decision makers. And so my plan here is essentially a decision aid platform that really integrates both systems architecture as kind of providing a lot of the backbone for the exploration. That's kind of where it would sit too in the decision process, is really early stage exploration, and also integrating better ways of eliciting stakeholder preferences, both through things like discrete choice experiments and things like that, but then also other approaches to participatory planning. So initial research questions around developing something like this concern what approaches to participatory planning can be most effective. How do you get people to the same table to talk about the same things, to elicit preferences and needs early on? How best to integrate discrete choice experiments and latent class analysis, things like that, into stakeholder engagement part of the systems architecture process. How to conduct architectural trade-offs, focusing on resilience and community outcomes with groups of people, and in full view of sort of competing interests. And similarly, how to structure the decision-making process around final architectural selection. And a big component of all this would be figuring out the best or better representations, graphical representations of architectures, or interactive representations of a design space. And on a couple of these, I'm currently working on grants with the Department of Defense, Office of Local Defense, on essentially looking into these 3 questions for infrastructure hardening in Colorado. So how to improve resilience across interconnected infrastructure systems to different forms of failures or attack. And that is, I'm a little early, that's all. So, thanks for everybody's time. And I'll take any questions.
Hey, Graeme.
Hey.
Thanks for coming.
Yeah.
I want to know if there's any functional barriers that you are facing that pretty much, I think, sort of restrict this protocol or architecture system you've built to early stage. Because if we look at mid stage or final stage, is that like a question of just shifting variables, or like why are we restricted to early stage, or are you just choosing early stage?
It's a great question. So it's not necessarily restricted to early stage. That's where it's been. That's where it's sort of been successfully deployed in other spaces. So like in aerospace and stuff, it really focuses on those early stage decisions. There's no reason necessarily why it couldn't be applied later on, but it's supposed to be, or it really shines in kind of figuring out these sort of high level things. So if you have high level questions to figure out sort of in later stages of engineering design, there's no reason why it wouldn't be helpful. But at that point, typically things are so nuanced and the architecture so sort of well defined that there's probably better tools. But yeah, other than that, I don't see anything like sort of structural getting in the way. Also, one thing that I looked into in my dissertation, I didn't talk about it here, was applying it to different parts of the infrastructure, overall infrastructure management, so not just early stage design, but also development, and then life cycle management as well. So different ways of structuring those to achieve stated outcomes.
Wonderful to see you again.
Yeah, you too.
Great to get to hear you talk. I wanted to ask a little bit about the tool that you made under the PhD, and I wasn't aware of that part. I wanted to ask, have you had the chance to do that kind of work in the postdoc, or where do you find yourself falling?
So I haven't yet. I started the postdoc in March, and I made it pretty clear that I wanted to brush up on a couple of skills that I didn't have in the postdoc, rather than just diving headlong into my own or someone else's research. So my focus has been slightly different, although, yeah, I mean, long term, I really want to. That's a big component of like kind of what I'd like to focus my time on, is that tool and making it a little bit more adaptable and broadly applicable. Does that answer your question?
Yeah, I have a follow-up, but maybe I'll defer to others first.
I feel like I missed part of your question. So.
Well, I guess how difficult? I suppose the big policy question is, you developed this fantastic tool in your PhD about the redevelopment of that highway, right?
Mm-hmm.
how likely is it to get into use? Right. Obviously, this is a tricky question, but what do you think the barriers would be for a tool like that? What kinds of barriers should we be thinking about?
Yeah. So, well, first of all, I almost certainly would never even approach New York City with it. Everybody involved, getting data for just the case study that I did was pretty tough because nobody likes to make any of it public in order to protect sort of their own bottom line and interests. So certainly not New York City. I think that's going to be true of a lot of different places. There are some parts of the country, though, smaller municipalities that are more, say their ethos is maybe a little bit more collaborative than it is combative. And so I think finding the right community to partner with is good. Also, one of the reasons why I wanted to work with the DoD on some of it was because they can kind of strong arm people. When they have big bases and things in areas, then their communities are more likely to play ball with them, and utilities are more likely to play ball with them. So that's sort of a side door. In terms of like building it out the way that I want and getting it in use, I have no idea. I think it'd be cool. I think it'd be really worth it. And I hope at some point in my career I can like make that case and make it happen, but I don't know.
You make a really interesting point that medium tier cities might be a really good spot for these system architecture power tools.
Mm-hmm.
I'm thinking not just yours, you're giving my ideas. Thank you.
Yeah. Any other questions?
She can go first.
Okay. Yeah, what's up?
So the reason why we need to do like a policy decision-making aided tool is for make one decision, right? And then every stakeholder has different needs and different baseline and different objectives. Are you also interested in like converting one stakeholders make comparable comparison of their objectives?
Like between different like municipalities or like different projects within the same city? Like what do you?
For example, the Brooklyn-Queens Expressway,
Yeah.
the residents' objectives are different from the city's perspective.
Oh, sure, yeah.
And then, like, you mentioned about the air quality and the cost and then the flow.
Mhm.
But is there any way we can, so these three are different.
Yeah.
But can we make that comparable?
Yeah, probably. I don't know that I would want to. One of the reasons why, so I didn't mention, so one of the cool things I think about systems architecture is you typically end up using like multi-objective optimization in some form, whether it's simple Pareto sorting or like an evolutionary algorithm. And I like that because it preserves all these different objectives in their natural units. And I don't like flattening some of those in complicated urban contexts like this. Because if you want to tell somebody like, oh yeah, well we can quantify air quality in terms of dollars it'll cost you in additional health care, it sounds kind of tone deaf. I don't think you necessarily want to tell your community like, oh yeah, like we put it into dollars, and so like this is how much more expensive your child's health care is going to be. Just to take an extreme example. So I like keeping them separate, but if you wanted to say for maybe not the community objectives, but say for like performance, those you can typically, or cost obviously, but performance you can usually combine into a single metric. So it just sort of depends on which set of metrics or like kind of which category they fall into. But the community ones, I like it because they don't. Great question though.
Yeah, my question is kind of similar to yours as well.
Uh-huh.
Because like you mentioned, like if you give me a value of AQI, there's no way for me to know for sure like what is healthy and what is like really terrible for me, right?
Mhm.
So but if you put it into dollars and cents, you kind of feel the pain.
Yeah.
So I was thinking like with the choice of metric give a better perception of what's the risk. And also, I guess I have a second question for your second
Mhm.
project as well. In terms of the analysis, you made a comparison between cities. And
Mhm.
I studied like city markets, and we know, I mean, I guess I have some perception of like what the prices of electricity could be in different regions.
Yeah.
And I mean, if you compare San Diego and you can reduce 1 kilowatt hour of power,
Right.
it has considerable energy savings compared to like maybe a place that's price capped in the PGM area that
Right.
2000 or whatnot. So the relative energy savings that you get in dollars and cents could be very different.
Yeah.
So I was wondering, like, what's your take on that? How do you compare between cities?
So there, I was just looking at willingness to pay. So I was really looking at just purely how to incentivize landlords in those different areas. So the actual energy savings, I don't look into. I looked at just the dollars saved, and the dollars that landlords could potentially add to or increase rent by. The actual impact of that on any particular energy grid, I haven't looked into. This is more that'd be sort of a secondary thing. I think it'd be really interesting to look into, but for this one, we were just mostly we were entirely focused on how to bridge that efficiency gap. Does that address your question? Yeah, okay. All right. Anything else?
Any other questions? Great, so let's thank Graeme again, wonderful talk.